You are breathing stolen air. Every atom of oxygen filling your lungs right now was forged inside a star that died before the sun existed, before the Earth was a thought, before this solar system had so much as a single grain of dust to its name. You do not own the oxygen in your blood. You inherited it. It passed through a stellar furnace that burned at 10 million degrees, through the violent death of a supernova that scattered it across a young galaxy, through 4 billion years of planetary chemistry, and then, through the most improbable sequence of events in the known universe, it arrived here, in you, right now, breathing. That story, the story of where oxygen comes from, is one of the most well-tested, most carefully verified stories in all of science. It takes time, enormous time. Stars must form, live, and die, multiple generations. The universe needs hundreds of millions of years minimum before oxygen can exist anywhere in meaningful quantities. This is not a controversial claim. It is chemistry, it is nuclear physics. It is the most basic constraint on what the early universe could have contained. And in March of 2025, that constraint was broken. 2 independent teams of astronomers, one led by Sander Schouws at Leiden Observatory in the Netherlands, another by Stefano Carniani at the Scuola Normale Superiore in Pisa. Italy both pointed the Atacama Large Millimeter Array at the same object, the same impossibly distant object. A galaxy called JWST GSZ 140, sitting at a redshift of 14.18, its light having travelled 13.4 billion years to reach us. We see it as it was when the universe was less than 300 million years old, less than 2% of its current age. They were not looking for oxygen. Nobody expected to find oxygen there. The universe, at 300 million years old, was supposed to be too young, too simple, too empty for anything as chemically complex as oxygen to exist in measurable amounts. They were looking to characterize the galaxy's structure, to measure its mass, its star formation rate, its basic physical properties. Both teams found the same thing: oxygen. Unmistakable. Burning in the spectrum of a galaxy that should not have had time to make it. Schouws described what he saw with 3 words that have since travelled around every cosmology department in the world. 3 words that are, in their quiet precision, among the most alarming things a scientist has said about the universe in a decade. It is like finding an adolescent where you would only expect babies. This was not a local anomaly. This was not a single data point from a single instrument. 2 completely independent teams, using independent analyses of the same ALMA data, confirmed the same oxygen detection simultaneously. They published in separate journals. They agreed on the measurement. They disagreed on what it means, and behind both their papers, in the institutional language of peer-reviewed science, was the same admission, dressed in careful academic phrasing. The galaxy is more chemically mature than expected. Formation of galaxies happens much faster than was expected. The evidence raises questions about when and how galaxies formed. Translation: we do not understand what we are looking at. Translation: the timeline is broken. Translation: something was here before we thought anything could be. And then, 4 months later, in January 2026, a team at Texas A&M University published a second paper in Nature Astronomy. They had found another system, a quintet of 5 galaxies colliding at redshift 6.71, roughly 800 million years after the Big Bang, now dubbed JWST's Quintet. And surrounding those 5 galaxies, stretching between them and beyond them, connecting them like a luminous thread, was an enormous halo of gas. A halo glowing with ionized oxygen. Oxygen that had been torn from the galaxies by the violence of their collision and scattered into the space between them, enriching the intergalactic medium hundreds of millions of years before any model predicted such enrichment was possible. The oxygen was outside the galaxies, not inside, outside, in the void, in the space between. Dr. Casey Papovich, professor of physics and astronomy at Texas A&M, did not mince his words. He said, "This discovery tells us our theories of how galaxies assemble and how quickly they do so need to be updated to match reality. 2 separate discoveries, 2 impossible oxygen detections, 2 systems that should not exist in the form they do, at the time they do, with the chemistry they carry." But here is what neither paper said. what none of the press releases mentioned, what no institutional statement has yet been willing to put into plain language. If there is that much oxygen that early, if the universe was enriched with oxygen on a timeline that our current models cannot explain, then the only coherent explanation is that the process that made that oxygen started earlier than the Big Bang itself. Not shortly after the Big Bang, before it. Because the oxygen is not just early, it is too early. It is so early that the stars required to make it would have had to begin forming in a universe that, according to every simulation, every model, every equation built on the standard cosmological framework, was not yet capable of forming stars at all, unless something else was already here, unless the Big Bang was not the beginning, unless what we call the beginning was actually a transition, a reset, a page turn in a book that has no first page. This is the story of the oxygen. This is the story of what it tells us, what it implies, and why Nobel laureate Roger Penrose, the man who worked alongside Hawking on the mathematics of black holes and spacetime, has been waiting for exactly this kind of evidence for 15 years. Because this evidence in his framework is not a mystery, it is a memory. The oxygen is not evidence of galaxies that form too fast. It is evidence of a universe that existed before ours. There are 7 things this oxygen reveals about the cosmos, 7 layers beneath the surface of the discovery, and by the time we reach the last one, the question will not be whether the Big Bang was the beginning. The question will be whether anything ever truly begins at all. Before we get started, if you love exploring the depths of space as much as we do, take a second to like this video and subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. Part 1. The element that cannot lie. Why oxygen is the perfect witness. Before we can understand why the oxygen discovery is terrifying, you need to understand why oxygen in particular is so important. Why not hydrogen? Why not helium? Why does the specific presence of oxygen and not some other element constitute a crisis rather than an anomaly? The answer is that oxygen is the perfect forensic witness. It cannot be faked, it cannot be confused for something else, and its presence in measurable quantities carries an ironclad record of the history that had to precede it. Here is what I mean. The Big Bang produced a menu of 3 elements: hydrogen, helium, and trace amounts of lithium. That is the complete inventory of primordial chemistry. Everything else on the periodic table, everything from carbon to iron to gold to uranium, is a product of stellar nucleosynthesis. It had to be manufactured, had to be assembled inside stars, had to be cooked at temperatures and pressures found only in stellar cores and supernova explosions. Oxygen specifically requires a process called the triple alpha reaction. You need a star. You need that star to exhaust its hydrogen fuel, a process that takes millions to hundreds of millions of years depending on the star's mass. Then you need the star's core to contract under gravity, heating up until helium nuclei alpha particles begin to fuse. 3 helium nuclei collide and combine to form carbon. Carbon then captures another helium nucleus and becomes oxygen. This is the machinery that makes oxygen. There is no shortcut. There is no alternate pathway. If you want oxygen, you need stars that have burned through their hydrogen and entered the helium burning phase. You need time. And you need the oxygen to escape. A star that makes oxygen in its core and simply holds it there until it fades quietly into a white dwarf releases almost nothing into the surrounding medium. For oxygen to enrich a galaxy, for it to appear in the interstellar gas, for it to show up in the spectrum of a galaxy's extended halo, you need violent stellar deaths. Supernovae. Asymptotic giant branch stars shedding their outer layers. Wolf-Rayet stars blowing off enormous winds. The oxygen has to get out of the star and into the universe. This process is not fast. Even for the most massive stars, the ones that live and die in only a few million years, the full cycle from formation to supernova to dispersal of heavy elements into the surrounding medium takes time that accumulates. Multiple generations of stars must live and die before the oxygen concentration in a galaxy's gas reservoir rises to levels detectable at cosmological distances. Current theoretical models, the most optimistic, most carefully calibrated simulations of early universe chemistry, predict that detectable oxygen enrichment should appear no earlier than approximately 500 million years after the Big Bang. 500 million years, that is the hard lower limit according to the standard framework. Below that, there is simply not enough time for the required stellar generations to complete their cycles. JWST 140 shows oxygen at 300 million years after the Big Bang. Not close to the limit, not within the margin of error, 200 million years before the earliest point the models allow. Schauser's team found that the galaxy contains 10 times more heavy elements than their models predicted. Not 10% more. 10 times more, an order of magnitude beyond expectation. Carniani's team, working independently, confirmed the same order of magnitude excess. This is not a measurement at the edge of detection. This is not a faint line that could be noise. This is a blazing, unambiguous oxygen signature in a galaxy that is, by the standard cosmological clock, far too young to possess it. The oxygen is not lying. The galaxy's age is not lying. The physics of nuclear fusion is not lying. One of the foundations those three true things are resting on must be wrong. And the most fundamental foundation of all the assumption that the Big Bang was the beginning, that there was nothing before it, that the universe started from zero, is the one that nobody in the institutional literature is yet willing to challenge in plain language. We are going to challenge it here. The scale of the impossibility. Let's make sure the scale of this lands properly. Let's put it in terms that are not abstract. The universe is 13.8 billion years old. JWST 140 existed when the universe was 300 million years old. That is 2.2% of the current age of the universe. If you compress the entire history of the universe into a single calendar year, 13.8 billion years mapped onto 365 days, then 300 million years corresponds to roughly 3 days after January 1st. 3 days into the year, this galaxy already had oxygen, already had 10 times more heavy elements than theory predicted, already had a chemical history that, if you read it like a geological record, implies stellar generations stretching back further than 3 days into the year. Further back, potentially, than day one. You are reading the chemistry and finding that the rocks were already ancient when the year supposedly started. Here is another way to think about the scale of the problem. The most massive stars that exist, stars 20 or 30 times the mass of the Sun, live for only a few million years before exploding as supernovae. They are the fastest element factories in the universe. In the 3 days our calendar analogy allows for building JWST 140's oxygen content, you could fit roughly 60 to 70 stellar lifetimes of the most massive stars. That sounds like a lot until you understand the numbers required. To enrich a galaxy of 500 million solar masses, which is what JWST 140 is estimated to contain, to an oxygen abundance 10 times above the primordial minimum, you need an extraordinary number of those stellar cycles to have completed. You need not just the stars themselves, but the dispersal of their products, the collapse of enriched gas into new stellar generations, the further enrichment of those generations, and the outflows and mergers that spread the chemistry throughout the galaxy's gas reservoir. 60 stellar lifetimes is not enough, not even close. The simulation models say you need at minimum several hundred million years of continuous star formation and death at very high rates to achieve what JWST 140 displays. The universe gave it 3 days. If the standard cosmological model is correct about when the universe began, then what produced this oxygen is not explicable within any current theoretical framework. The researchers who publish these papers know this. They say so in the careful institutional language of peer-reviewed science. They describe the result as challenging previous assumptions about the timeline of heavy element production. They call for updated theories of galaxy assembly. They invite the field to revise its models. What they do not say, what none of them can yet say, in the context of their institutions and their careers, is what one physicist has been saying for 15 years. A physicist who won the Nobel Prize in 2020, a physicist who has spent decades building the mathematical framework for a universe that does not start from nothing because it never started at all. His name is Roger Penrose, and this oxygen, in his framework, is not a crisis. It is a receipt. Part 2. The man who said the universe has no beginning. Penrose and the cyclic universe. Roger Penrose is not a fringe theorist. He is not a contrarian or a sensationalist. he is one of the most rigorous mathematical physicists alive on Earth today. He shared the 2020 Nobel Prize in Physics for his proof that black holes are a necessary consequence of Einstein's general relativity, a mathematical proof that changed how physicists think about singularities, about information, about the structure of space-time itself. He worked alongside Stephen Hawking on theorems that remain foundational to the field. He is also the architect of the most radical cosmological proposal of the past half-century. He calls it Conformal Cyclic Cosmology, CCC, and it predicts from first principles that the early universe should contain exactly the kind of chemical anomalies that James Webb and ALMA are now finding. Here is the idea, stripped of mathematics. The Big Bang, in the Standard Model, is a singularity, a point of infinite density, infinite temperature, infinite curvature of space-time, a true beginning, a moment before which there was nothing, not just no matter, not just no energy, but no space and no time. The Standard Model says the universe was created at that moment, and before it, there was not a before, because the concept of before requires time, and time did not exist. Penrose looks at that description and says, "I do not believe it. Not for philosophical reasons, for mathematical ones." His argument begins with entropy. The second law of thermodynamics states that entropy disorder, disorganization, the tendency of systems to move from structured to unstructured states, always increases in a closed system over time. The universe, as it ages, becomes more disordered. Stars burn out, galaxies cease forming new stars, matter falls into black holes. The overall entropy of the universe increases monotonically. This creates a problem for the Big Bang. If the universe started at the Big Bang and the Big Bang was a singularity of maximum density, then the Big Bang should have been a state of maximum entropy, maximum disorder, maximum randomness. But observations of the cosmic microwave background tell us that the early universe was extraordinarily smooth, extraordinarily uniform, extraordinarily low in entropy. The Big Bang was not a high-entropy explosion, it was a low-entropy beginning. How do you get a low-entropy Big Bang from nothing? How do you start with maximum order in a universe that supposedly came from a state of infinite density and temperature? This is the entropy problem of cosmology, and it has no clean solution within the Standard Model. Inflationary cosmology attempts a partial answer, but it introduces its own entropy paradoxes that remain unresolved. Penrose's answer is radical. The Big Bang was not a beginning. It was a transition, a phase change, and what it transitioned from was the end state of a previous universe. Here is the mathematics in conceptual form. A universe at maximum entropy at the heat-death end state, when all black holes have evaporated through Hawking radiation, when all matter has been converted to photons and other massless particles, is a universe that has lost all meaningful scale. A universe of massless particles has no intrinsic length scale. In a universe of massless particles, the concept of distance becomes meaningless in a deep mathematical sense. And here is the extraordinary thing Penrose identified. A universe that is geometrically infinite and smoothly distributed with no length scale is conformally equivalent to a universe that is geometrically tiny and smoothly distributed with no length scale. The mathematical description of an infinitely expanded, maximally entropic end-state universe is identical to the mathematical description of a Big Bang singularity. The end of one universe is the same mathematical object as the beginning of the next. The transition happens automatically. It is not driven by any external force. It does not require a creator or a cause. It is a mathematical inevitability, built into the geometry of space-time in a universe with a positive cosmological constant, which our universe appears to have, as evidenced by the accelerating expansion. In Penrose's framework, the universe cycles through an infinite sequence of aeons. Each aeon begins as a Big Bang, expands for trillions upon trillions of years, ends with the evaporation of the last black hole, and transitions into the next Big Bang. The transition is seamless. The low entropy of the Big Bang is explained. It inherits the smoothed-out geometry of the previous aeon's heat death. The end state of maximum entropy in one aeon becomes the starting state of minimum entropy in the next. This is the architecture. This is the mathematics. And within this architecture, the oxygen in JADES GSZ 140 is not impossible. It is inherited. What survived the transition. If CCC is correct, the transition between eons is not a perfect reset. It is a phase transition, like water turning to steam. In a phase transition, most of the information of the previous state is lost or scrambled, but not all of it. Some things survive. The smoothed-out geometry of the previous aeon's end state survives as the low-entropy initial condition of the new aeon. The gravitational information of the largest structures, the mass distributions that determined where the supermassive black holes were, where the galaxy clusters were, where the largest density enhancements were, leaves an imprint on the new universe's initial conditions. The distribution of dark matter and dark energy in the new aeon carries, in some sense, the shadow of the previous aeon's structure. And what is the shadow of a universe that spent trillions of years building stars, galaxies, galaxy clusters, supermassive black holes, a universe that ran complete stellar cycles billions of times, that seeded and reseeded the interstellar medium, with every heavy element up through the periodic table? What is the shadow of all that chemical history? It is a pre-enriched universe. A universe whose initial conditions already contain, encoded in the density distributions and quantum fields inherited from the previous aeon, the preference for rapid, chemically complex structure formation. The first galaxies of our aeon are not starting from scratch. They are reading from a template. They are building on foundations laid in the previous universe. They are assembling themselves in regions of space where the gravitational scaffolding from the previous aeon's largest structures left behind an enhanced density of dark matter, a pre-organized web for baryonic matter to fall into. And they are doing so with a quantum vacuum that has been shaped ever so slightly by the particle physics of the previous aeon. Think about the analogy carefully. You inherit a house. The house is empty. Everything was cleared out when the previous owner left. But the house is not truly empty. The walls are there. The plumbing runs to specific locations. The electrical wiring follows paths laid down by the previous owner's decisions. The garden has soil that was cultivated over years. You start fresh in an already organized space. The early universe, in Penrose's framework, is that house. The Big Bang cleared the inventory, but the structure was already there. And the galaxies that form first, the ones that appear impossibly early, impossibly massive, impossibly enriched with heavy elements, are the ones building on the parts of the previous structure that transmitted most cleanly through the transition. The oxygen in JWST 140 is not evidence that oxygen formed faster than physics allows. It is evidence that the regions of space where that galaxy assembled were pre-organized by the previous eon in ways that accelerated their chemical evolution. The stellar generations required to make that oxygen may have run in a universe that no longer exists. The product was preserved in the initial conditions of ours. The oxygen did not form after our Big Bang. It arrived at our Big Bang already encoded in the fabric of what was to come. Part 3. The Scars on the Oldest Light. What Penrose predicted. Here is where the theory stops being philosophy and becomes physics. Here is where it makes testable predictions. Here is where the critics sharpened their pencils and where the data, slowly, painfully slowly, began to respond. Penrose and his colleague Christoph Meissner at the University of Warsaw made a specific prediction about what the transition between eons would leave in the cosmic microwave background of the new universe. The CMB, the faint glow of radiation left over from 380,000 years after the Big Bang, the oldest electromagnetic signal in our universe should, if CCC is correct, carry imprints from the events of the previous aeon. Specifically, supermassive black holes. In the final epochs of the previous eon, as the last galaxies burned out and the last stars faded, the dominant structures remaining would be the supermassive black holes at the centers of dead galaxy clusters, objects billions of times more massive than our Sun. And those black holes over extraordinarily long timescales measured in numbers that cannot be spoken without exponent notation, would evaporate through Hawking radiation. The final evaporation of a supermassive black hole would release an enormous burst of energy. A final cry of electromagnetic radiation from an object that had been silently shrinking for a period of time longer than the current age of the universe by many orders of magnitude. That burst would be concentrated, Penrose argued, by the conformal geometry of the transition between eons. The energy from the evaporation would be stretched by the conformal mapping and would appear in the new Aeon CMB as a hotspot, a roughly circular patch of elevated temperature, an anomalously bright region against the otherwise uniform cosmic microwave background. He called these Hawking points. And not just hotspots. Penrose predicted that surrounding each Hawking point there would be concentric rings of low temperature variance, the gravitational ripples of the black hole merger events that preceded the final evaporation, smeared into circular patterns by the conformal mapping. Rings within rings, ghostly echoes of collisions that happened before our universe began. Penrose, working with Vahe Guzadian, searched the WMAP and Planck CMB datasets. They published papers claiming to have identified multiple Hawking point candidates anomalously bright spots with the predicted angular size and temperature profile. They claimed statistical significance. Other groups disputed the analysis. A team using machine learning searched 50 million candidate center positions in the high-resolution Planck data and reported that, when proper statistical controls were applied, the evidence for Hawking points was not statistically significant. The debate has been ongoing, published, contested, and reanalyzed for nearly a decade. The status of Hawking point evidence is genuinely disputed. I am not going to tell you the controversy is settled, because it is not. Penrose believes the signal is real. Other analysts believe it is not above the noise floor. What I will tell you is this: the existence of the debate is itself important. The question is live. The data is ambiguous in a way that keeps the possibility open. And in the context of the oxygen discoveries, the JADES-GSZ 140 detection, the JWST's Quintet oxygen halo, the question of whether the CMB contains imprints from a previous Aeon is no longer an idle theoretical puzzle. It is directly relevant to the most pressing observational crisis in modern cosmology. If the oxygen is from before, then there must be other signatures, other echoes, and the CMB is the most natural place to look. The temperature map and its anomalies. The cosmic microwave background is the most thoroughly studied object in observational cosmology. The Planck satellite mapped it at sub-degree angular resolution over the entire sky. The temperature variations are understood at the level of parts per 100,000. The statistical properties of those temperature variations, their power spectrum, their higher-order correlations, their departures from perfect Gaussian statistics have been analysed with extraordinary precision, and the CMB is not perfectly normal. There are several well-documented large-scale anomalies in the CMB that have no explanation within the standard lambda CDM model. The power at the largest angular scales larger than about 60 degrees on the sky, is suppressed compared to what inflation predicts. There is an alignment of the quadrupole and octopole moments, the largest scale temperature patterns, that is statistically improbable in a perfectly Gaussian random field. There is the cold spot, a region in the southern sky that is anomalously cold, with an angular size of roughly 5 degrees, that cannot be fully explained by any known foreground effect or by standard vacuum supervoid models. These anomalies have been known since the WMAP data was first released in 2003. They have survived every reanalysis. They are real features of the actual CMB sky, and they sit there in every paper that discusses them, wearing the most damning label in empirical science, unexplained. The standard cosmological model cannot generate these anomalies from its first principles. Inflation, the leading theoretical framework for the very early universe, predicts that the CMB should be, to excellent approximation, a Gaussian random field with no preferred direction and no preferred angular scale above a certain size. The large-scale anomalies violate this prediction. They do not violate it dramatically. The discrepancies are not enormous. They are at the level of 1 standard deviation, 2 standard deviations unusual but not unheard of. It is possible in principle that they are statistical flukes, that in the random cosmic lottery, the patch of universe we observe happens to have drawn an unusual ticket on the largest scales. But then there is the oxygen. And there is the oxygen halo in JWST's Quintet, and there are the dozen anomalously massive, anomalously bright, anomalously chemically complex galaxies that James Webb has been finding in the epoch of cosmic dawn since its first light in 2022. When multiple independent anomalies all point in the same direction when the early galaxies are too chemically advanced, when the CMB has unexplained large-scale structure, when the dark flow suggests an influence from beyond the observable horizon, when the Hubble tension reveals a universe expanding faster in the local epoch than the early epoch predictions allow, you are no longer dealing with statistical flukes in separate datasets. You are dealing with a pattern, and patterns have causes. Part 4. The oxygen halo outside the galaxies. JWST's Quintet and the evidence that changes everything. Let's go back to the second discovery, the one from January 2026. The one that, in some ways, is even more troubling than the JADES-GSZ140 oxygen detection. JWST's Quintet, redshift 6.71, 5 galaxies colliding in a region of space, approximately 24 by 24 kiloparsecs across roughly 80 light-years on a side in today's scales. 17 galaxy-sized clumps within that region, a combined stellar mass of 10 billion solar masses, a star formation rate of 240 to 270 solar masses per year, 10 times the current star formation rate of the entire Milky Way, packed into a region hundreds of times smaller. At 800 million years after the Big Bang, this system is already an extraordinary object. The mass alone is startling. The star formation rate is startling. But the discovery that Wiedehoe and Casey Popovich's team published in Nature Astronomy is not about the galaxies themselves. It is about what surrounds them. The extended oxygen halo. Here is what they found. Connecting 4 of the 5 galaxies and extending beyond them into the intergalactic medium is a large nebula of glowing gas. That gas emits light at the specific wavelengths characteristic of ionized oxygen and ionized hydrogen. The oxygen is not inside the galaxies, it is between them and around them, in the space that, according to standard models of cosmic chemical evolution, should contain almost nothing but pristine hydrogen. The mechanism, the researchers argue, is tidal stripping and galactic outflows driven by the collision. When 5 massive star-forming galaxies ram into each other at high velocity, the gravitational tidal forces are violent enough to strip material from each galaxy's outer regions and scatter it into the intergalactic medium. And some of what gets stripped is chemically enriched gas that has already been processed through stellar cycles, that already contains oxygen and other heavy elements forged in stellar furnaces. This mechanism is real. Tidal stripping does happen. Galaxy mergers do enrich the intergalactic medium. The disagreement is not about the physics of the mechanism. The disagreement is about the timing. For tidal stripping of oxygen-rich gas to be happening at 800 million years after the Big Bang, the galaxies doing the stripping must already be chemically enriched before the stripping event. They must already have oxygen in their outer gas reservoirs, which means the stellar generations required to make that oxygen must have completed before 800 million years after the Big Bang in galaxies that would have been forming in the period from roughly 300 to 600 million years after the Big Bang, which is the same period that JADES-GSZ140 occupies. These 2 discoveries are not independent. They are 2 observations of the same underlying reality. JADES-GSZ140 shows us that oxygen enrichment was happening by 300 million years after the Big Bang. JWST's Quintet shows us that by 800 million years after the Big Bang, that enrichment had progressed far enough that galaxies were already stripping it into the intergalactic medium at scale. The timeline is not just wrong at one point, it is wrong across an extended epoch. The chemical evolution of the universe happened everywhere, across hundreds of millions of years, faster than any model predicted. Popovich's team noted that this discovery implies galaxy-galaxy interactions were shaping the chemical composition of the intergalactic medium far earlier than expected. Models of cosmic chemical evolution typically place significant intergalactic enrichment at redshifts below 4, meaning after 1.5 billion years of cosmic history. Finding it at redshift 6.71, at less than 800 million years, moves the clock forward by more than 700 million years. 700 million years is not a rounding error. 700 million years is longer than the time it took complex multicellular life to evolve on Earth after the first eukaryotic cells appeared. The universe's chemical history is not slightly off. It is an entirely different story from the one we thought we were reading. Part 5. The Broken Clock and the Missing Time. The Hubble Tension, revisited through the lens of oxygen. We need to talk about the broken ruler again, because in the context of the oxygen discoveries, the Hubble tension takes on a new dimension of significance that its discoverers did not anticipate. The Hubble tension is the disagreement between two independent measurements of how fast the universe is expanding. Method 1, based on the cosmic microwave background, the ancient light from 380,000 years after the Big Bang, gives a Hubble constant of 67 km per second per megaparsec. Method 2, based on local measurements of Cepheid variable stars and type Ia supernovae in nearby galaxies, gives 73 km per second per megaparsec. The James Webb Space Telescope was supposed to resolve this discrepancy. It observed Cepheid stars with unprecedented precision, removing the largest sources of systematic error that had plagued previous measurements. It did not close the gap. It hardened it. The Webb data confirmed, at higher confidence than ever before, that the local universe is genuinely expanding faster than the early universe prediction. The standard response to the Hubble tension is to invoke new physics, early dark energy, a modification to gravity, additional radiation species in the early universe that could change the expansion rate at specific epochs without destroying the rest of the cosmological model. These proposals are being actively explored. None of them is fully satisfying. Each one that fixes the Hubble tension creates new discrepancies elsewhere. But here is what nobody has said clearly in the published literature. If the universe underwent a conformal transition from a previous eon, as Penrose's CCC proposes, the Hubble tension is expected. It is a prediction of the framework, not a bug to be corrected. Here is why. The conformal mapping between the end of the previous aeon and the beginning of our aeon is not a perfect mathematical identity in the presence of massive objects. The regions of our universe that inherited the strongest gravitational templates from the previous aeon structure, the regions that became the largest galaxy, clusters and superclusters would have their local expansion, rate modified by the gravitational inheritance in ways that are not captured by the standard homogeneous isotropic model. The local universe, in a CCC framework, would expand at a rate reflecting both its current matter content and its inherited gravitational structure. The early universe, measured through the CMB, would reflect the purely thermal, smoothed-out state of the aeon transition. These two measurements would disagree by a systematic offset. An offset of the right sign local faster than CMB predicted, and the right magnitude approximately 8 to 10% to match the observed Hubble tension. The oxygen tells us the chemical history is wrong. The Hubble tension tells us the expansion history is wrong. Both point in the same direction. Both are consistent with a universe that did not start from nothing. Both are consistent with a universe that started from something. The matter that should not be there. Here is one more brick in the wall. One more anomaly that, when you add it to the others, forms a structure too coherent to be coincidence. When the James Webb Telescope surveys the distant universe, when it maps the distribution of massive galaxies at redshifts between 6 and 14, it finds more massive galaxies than the standard model predicts. Not slightly more, significantly more. The number density of massive, luminous galaxies in the first billion years of cosmic history is, according to multiple published papers, orders of magnitude higher than lambda CDM simulations predict. This is the problem that Ivo Labbé and his colleagues at Swinburne University of Technology highlighted in a 2023 Nature paper that used early Webb data. They found 6 candidate galaxies with photometric properties suggesting they were as massive as the Milky Way, existing at redshifts between 7 and 10. The expected number, based on standard models, was effectively 0. The observed number was 6, and the authors noted that even if some of these candidates turned out to be lower redshift interlopers, the remainder would still represent a severe overproduction of early massive galaxies. Ethan Siegel, commenting on the study, described the finding as, "Even if we cut the sample in half, this is still an astounding change." Since that initial finding, spectroscopic follow-up has confirmed many of these candidates as genuinely high redshift objects. The overproduction of early massive galaxies is not a photometric artifact. It is a real feature of the universe. Where did all that mass come from? Standard lambda CDM says it cannot be there because the dark matter scaffolding the invisible web that normal matter falls into cannot concentrate fast enough to build those structures in the available time. You need dark matter halos to form first, then gas to fall into them, then stars to form, then stellar evolution to proceed, then the cycle of stellar death and enrichment to run. You cannot compress that chain into the time available without violating the physics of gravitational collapse, unless the dark matter web was already there. Unless the scaffolding was not built from scratch by our universe's Big Bang, unless the large-scale gravitational structure, the map of where matter wants to cluster, was inherited from the previous aeon, already partially assembled, waiting for the new universe's baryonic matter to fall into it along paths that were pre-organized by the previous universe's death. In CCC, the dark matter distribution of our universe is not a product of random quantum fluctuations amplified by inflation. It is, at least in part, a shadow of the previous universe's mass distribution. The places where matter concentrated in the previous eon, the galaxy clusters, the superclusters, the great walls of structure, left gravitational imprints that shaped where matter concentrated first in our eon. The overabundance of early massive galaxies is not a violation of physics. It is a violation of the assumption that our universe started from scratch. When you account for inherited gravitational structure, when you build in the organizing information from the previous aeon, the early massive galaxy problem dissolves. Not because the physics of structure formation changes, but because the initial conditions are not random. They are informed. They carry memory. Part 6. What oxygen means for life. The biogenic elements and the cosmic calendar. We established that oxygen is impossible at 300 million years post-Big Bang according to the Standard Model. Let's now follow that thread somewhere you may not have anticipated. Oxygen is not just a cosmological curiosity. Oxygen is the third most abundant element in the universe by mass. It is the most abundant element in Earth's crust. It is in your water, in your bones, in every protein in your body. The carbon-oxygen chemistry that underlies all known biology on Earth is not a coincidence of planetary chemistry. It is a consequence of stellar nucleosynthesis. Carbon and oxygen are produced together in the same stellar cores through the triple alpha process and the subsequent capture reactions. They are cosmically linked. If oxygen was present at 300 million years post-Big Bang, if the universe was chemically enriched enough at that epoch to show oxygen in galaxy spectra, then carbon was also present. Not just in trace amounts, but in significant quantities, because the carbon-to-oxygen ratio in stellar nucleosynthesis is approximately fixed by the reaction pathways. You cannot have one without having the other. Carbon and oxygen together at 300 million years after the Big Bang. Now think about what that means. The universe has been host to the biogenic elements, the raw chemical ingredients of life as we know it, for essentially the entire observable history of cosmic time. If JWST 140 had oxygen at 300 million years, and if its descendants had planets, rocky worlds with liquid water and chemical gradients, those planets could in principle have hosted prebiotic chemistry. Not necessarily life. The requirements go well beyond the mere presence of carbon and oxygen. You need liquid water. You need energy gradients. You need shelter from radiation. You need time for chemistry to complexify. But the point is that the starting gun for the possibility of life was fired far earlier than we thought, not 500 million years after the Big Bang, as the Standard Model implies. Not even at 300 million years as JWST 140 implies. If CCC is correct and the oxygen traces its lineage to the previous eon, then the biogenic elements may have been present at the very beginning of our universe's Big Bang, carried through the conformal transition as an imprint of the previous aeon's chemistry. The universe may have been biogenic from the moment it began. Now follow that to its logical conclusion. If the biogenic elements were present from near the beginning, and if the universe is 13.8 billion years old, then the window for the development of life extends back much further than we previously imagined. Civilizations, if they existed, would have had not just the last 4 billion years of Earth's habitability to develop. They would have had potentially 10, 11, 12 billion years of cosmic habitability from the first chemically enriched systems onward. Where are they? The silence of the universe, the total, complete, unbroken absence of any evidence of intelligence anywhere in the cosmos, becomes even more confusing in the light of the oxygen discoveries. If the ingredients were there earlier than we thought, if the window for life's development was longer than we believed, then the Fermi paradox is not slightly more acute, it is vastly more acute. The absence of any detected intelligence in a universe that has been chemically ready for biology for nearly its entire history is either the most profound evidence for the rare earth hypothesis, life is a one-time accident, or it is a clue about what happens to every civilization that reaches the technological threshold we have just crossed. We will return to this, but keep the question open. Let it sit in the background, because the oxygen is not just an astronomical curiosity, it is a clue about what is possible in this universe. And the silence that surrounds it is a clue about what happens to everything that tries. Part 7. The topology of time. Before. Let's go somewhere that even most physicists are reluctant to follow. Let's ask the question that the oxygen, taken seriously, eventually demands. What does it mean to say something was here before the Big Bang? In everyday language, before is simple. There is a moment in time, and there are moments that precede it. But the Big Bang, in the standard model, is not a moment in time in the ordinary sense. It is a singularity, a boundary in the mathematical description of the universe, a point at which the equations of general relativity break down and can no longer be extrapolated. It is the edge of the map. Before the Big Bang, in the standard model, there is no map. Not just unexplored territory, no map. This is why the statement, "something was here before the Big Bang," is not just empirically challenging, it is conceptually challenging. It implies that the concept of before applies to the Big Bang, that the Big Bang sits on a timeline that extends in both directions. Penrose's CCC provides the mathematical framework for how this works. The key is that the conformal boundary between eons is not a singularity in the pathological sense of the standard Big Bang. It is a smooth geometric surface, a crossover surface, Penrose calls it, where the mathematical description of the universe undergoes a conformal rescaling. Everything is rescaled by a factor that takes the infinity of the previous aeon's expansion and maps it onto the finitude of the new aeon's beginning. The physics does not break down at this surface. It undergoes a transformation. In this framework, the word before does not carry its usual everyday meaning at the crossover. The previous aeon is not earlier in the sense that Tuesday is earlier than Wednesday. It is earlier in the sense that a previous draft of a document is earlier than the current one. The information is connected. The causal thread runs through. But the temporal relationship is not the same as the one we use in daily life. And here is what that means for the oxygen. The oxygen in JWST 140 did not travel through the crossover surface. Atoms, molecules, stellar remnants, these do not survive the conformal transition. The transition converts all massive particles to massless radiation in the mathematical sense, and the universe begins again as a hot plasma, with no material relics of the previous aeon. What does survive is information, not material relics, not atoms, not molecules. But the quantum information encoded in the gravitational field, in the density perturbations, in the initial state of the quantum fields that permeate all space. Information survives in the structure of the thing that makes matter condense into the first galaxies, in the shape of the density map, in the locations of the first dark matter halos, in the gravitational wells that the first baryonic matter falls into. And if the previous aeon ended with a universe that had been processing matter through stellar cycles for trillions of years, if the previous aeon's galaxy clusters had reached chemical maturity that our aeon has not yet reached, then the gravitational information from those mature structures would encode, in the density map of our Big Bang's initial conditions, the template for where early rapid chemical enrichment would occur. The regions that became JWST 140 were not random locations, they were special. They were locations that received an enhanced gravitational inheritance from the previous aeon regions, that were predisposed to early rapid star formation, that fell into the deepest dark matter wells and began running their stellar cycles at the fastest possible rate, because the dark matter wells themselves were shaped by the mass distribution of the previous universe's death. The oxygen is not from the previous aeon, it was made in our aeon. but it was made at a pace and location that was determined by information from before our universe began. That is the most coherent reading of the data. Other models, and why they fall short. Let's be intellectually honest here. Let's ask, are there other explanations? Are there models within the standard Big Bang framework that can account for what James Webb and ALMA are finding? Yes, several have been proposed. Let's examine them fairly. The first category invokes very high-mass initial stellar populations. The idea is that the very first stars, population 3 stars, the first generation of stars in the universe, forming from pristine hydrogen and helium, were systematically much more massive than stars forming today, stars of hundreds or even thousands of solar masses, stars that live for only a few million years before exploding as hypernovae, releasing far more energy and far more heavy elements per stellar death than ordinary supernovae. If the first stars were extremely top-heavy, meaning the stellar initial mass function was skewed dramatically toward very massive objects, then stellar chemical enrichment could proceed much faster than standard models. Predict. This is a real possibility that the field takes seriously. There is theoretical motivation for thinking the first stellar generation would be more massive on average than subsequent generations, because the lack of cooling mechanisms in pristine hydrogen-helium gas would allow fragmentation into much larger clumps. The simulations support this direction qualitatively. The problem is quantitative. Even with the most extreme top-heavy initial mass function that astrophysicists find plausible, the rate of chemical enrichment achievable in 300 million years falls short of what JWST Quintet displays by a significant margin. The 10 times expected heavy element abundance is not achievable through top-heavy stellar populations alone. You can close part of the gap. You cannot close all of it. The second category invokes very early galaxy formation, the idea that density fluctuations in the early universe were somehow larger than inflation predicts, leading to much earlier gravitational collapse and star formation. If the first dark matter halos formed earlier than the standard model says, the first stars could have appeared as early as 100 to 150 million years after the Big Bang, rather than the standard 200 to 300 million years. That extra time could allow more stellar generations to complete their cycles before we observe JWST Quintet. Again, this is a real direction of theoretical exploration, and again, it partially addresses the problem without fully solving it. The density fluctuations required to generate the observed number density of early massive galaxies exceed the range that inflation comfortably predicts. You can adjust the parameters of inflationary models to generate larger fluctuations, but doing so tends to create other problems inconsistencies with the CMB power spectrum, overproduction of primordial gravitational waves, excessive non-Gaussianity in the CMB that the Planck data does not support. The third category proposes modifications to the dark matter model: self-interacting dark matter, fuzzy dark matter, axion dark matter that could change the rate at which dark matter halos form in the early universe. Some of these modified dark matter models do predict earlier and more abundant halo formation, which would speed up the assembly of early galaxies. These proposals are genuinely interesting and actively explored, but they suffer from a structural problem. They are epicycles. They are modifications added specifically to patch the early galaxy problem, without independent theoretical motivation from first principles. The history of physics is not kind to epicyclic models. When a theory requires repeated ad hoc modifications to match new data, the modifications are usually not the right answer. The right answer is usually a deeper revision of the underlying framework. And the deeper revision, the one that addresses not just the early galaxies but also the Hubble tension, the CMB large-scale anomalies, the dark flow, the overabundance of massive early galaxies, and the oxygen impossible timeline problem simultaneously, is Penrose's framework. Not because it is the only possibility, but because it is the only framework that explains all the anomalies with a single structural change, rather than requiring a separate patch for each one. Part 8. The silence in a universe with ancient oxygen. The Fermi paradox gets worse. We need to stay with the silence for a while, because the oxygen discoveries make it worse in a very specific way. The classic Fermi paradox is this: given the age of the universe, the number of stars, and the apparent chemical universality of the ingredients for life, We would expect that if technological civilization is a natural outcome of biological evolution, the galaxy should be full of it. Full of radio signals, full of megastructures, full of Dyson spheres and von Neumann probes and stellar engineering projects visible across light years. And yet we see nothing. We detect nothing. The sky is silent. The standard resolution attempts fall into two categories. Either life is rare, the rare Earth hypothesis, the great filter behind us, or civilizations are common but silent, hidden, absent from our detection methods for reasons we do not understand. The oxygen from JWST 140 adds a dimension that none of the standard analyses have incorporated. If CCC is correct, if the previous aeon existed, spent trillions of years evolving stars and galaxies and the chemical ingredients of life, and if the information from that aeon's chemical maturity was impressed onto the initial conditions of our Big Bang, then the question shifts from where are they to something far more specific. Where are the civilizations that should have developed in the previous aeon? If Penrose's framework is correct, then there existed a universe before ours that ran for incomprehensibly longer than ours has so far. A universe that had the same physics, we have the same nuclear reactions, the same gravitational dynamics, the same chemistry. A universe that produced stars and galaxies and planetary systems and, in the right conditions, the chemistry of carbon-oxygen biology. A universe that had orders of magnitude more time for life to develop and spread than our universe has had. In that previous aeon, if intelligent technological civilization arose, it would have had trillions of years to spread through its galaxy. Not thousands, not millions, trillions. In trillions of years, travelling at even a tiny fraction of the speed of light, a civilization that expands even at geological rates fills the entire observable universe many times over. Where is the evidence of that civilization? The answer, from the evidence we can access, is stark. We see no megastructures in the CMB. We see no evidence of intelligently organized matter in the structure of our galaxy's early formation. We see no Dyson sphere-scale engineering signatures in the infrared background. The previous eon, if it existed, appears to have been as quiet as devoid of technological civilization's signatures as our own eon appears to be. This is either evidence against CCC if there was a previous eon and it produced no civilization. Perhaps the framework is wrong, or it is evidence for the deepest version of the Great Filter hypothesis. Perhaps the emergence of intelligence is so rare, so dependent on such an unlikely convergence of factors, that it does not occur even once in an aeon that lasts trillions of years and contains billions of galaxies. Perhaps we are not just the only civilization in our observable universe. Perhaps we are the only civilization in the entire cyclic history of the cosmos. Or perhaps civilizations emerge, but they do not persist. Perhaps intelligence is a solution to local entropy problems that eventually contributes to the large-scale entropy increase rather than reducing it. Perhaps every civilization that develops technology eventually transitions to a form of organization, digital, quantum, non-material that leaves no electromagnetic or gravitational signature. Perhaps the silence is not absence but transcendence. The oxygen does not answer these questions, but it reshapes them. It extends the timeline over which we are asking them, and it makes the silence more profound, more complete, and more demanding of explanation than it was before March 2025. Part 9. The Physics at the Edge of Everything. Dark Energy, CCC, and the Fate Already Written. Let's talk about what happens at the other end. Not the beginning, the end, where our universe is going, and what that end implies about the existence of a next beginning. The universe is expanding. It has been expanding since the Big Bang, and the expansion is accelerating. The dominant energy component is the cosmological constant, the mysterious energy of empty space that drives everything apart at an ever-increasing rate. In several billion years, the Milky Way and Andromeda will merge. The merged galaxy will sit in an increasingly empty bubble as all other galaxies recede beyond our observable horizon. In tens of billions of years, the last stars will exhaust their fuel. The stellar era will end. In hundreds of billions to trillions of years, the stellar remnants, white dwarfs, neutron stars, black holes will slowly cool and decay. And then the black holes. Over timescales that make the current age of the universe look infinitesimally small, timescales measured in numbers like 10 to the power of 100 years, the last supermassive black holes will evaporate through Hawking. Radiation. One photon at a time, each emission infinitesimally slow, but in infinite time, even the largest black hole will eventually radiate away the last of its mass. And when the last black hole evaporates in the last microsecond of the last black hole's existence in this eon, the universe will consist entirely of photons and other massless particles. An infinitely expanding sea of massless radiation with no structure, no scale, no matter. The geometry of that universe, Penrose says, is conformally equivalent to a Big Bang singularity. The mathematical description matches. The conformal transition happens. The next aeon begins. Dark energy, the cosmological constant, is not just an annoying puzzle in this framework. It is the engine. It is what drives the previous eon to the state required for the transition. Without dark energy causing the accelerating expansion, without that expansion clearing away all matter and all massive particles, the conformal equivalence with the next Big Bang does not hold. The presence of dark energy in our universe is, in Penrose's framework, not just an observation to be explained. It is a necessary feature of the mechanism that generates the next universe. Our universe has dark energy. Our universe will accelerate to heat death. Our universe will generate the conditions for the next Big Bang. We are the previous aeon, and somewhere in the cold death of our universe's final stars, in the oxygen we leave scattered through the intergalactic medium, in the carbon and nitrogen and iron seeded into the void by our stellar generations, somewhere, in all of that chemistry we have already produced, is the template that will shape where the next universe is first impossible. Galaxies form with oxygen that no one in that universe will be able to explain. We are the inheritance. We are the anomaly someone in the next aeon will find. The information that cannot die. Here is the deepest implication, the one that sits underneath everything else we have discussed and gives it a different colour. In standard quantum mechanics, information is conserved. This is not a philosophical claim. It is a mathematical requirement of unitary evolution, the principle that the quantum mechanical description of a system evolves in a way that preserves all the information contained in its initial state. You cannot, in principle, destroy information in a quantum system. You can scramble it, you can make it inaccessible, you can distribute it across a system so thoroughly that retrieving any particular piece of it requires knowledge of the entire system. But you cannot destroy it. Black holes created a problem for this principle. Stephen Hawking's 1974 calculation showed that black holes radiate thermally, that the radiation they emit does not carry specific information about what fell in, only thermal statistics. If a black hole evaporates completely, the information of everything that fell into it appears to be lost. This is the black hole information paradox. It has been a central problem of theoretical physics for 50 years. The current leading resolution, driven by the work of Juan Maldacena and the ADS CFT correspondence, and by subsequent calculations using holographic principles, is that information is not lost. It is encoded in the correlations of the Hawking radiation, scrambled in a way that makes it practically inaccessible but in principle recoverable. The black hole, over its full evaporation lifetime, emits radiation that carries the quantum information of everything it consumed. If information is conserved through black hole evaporation, if Hawking radiation carries, in scrambled form, the full quantum state of everything, the black hole ever absorbed, then the final radiation of a dying black hole carries, encoded in its quantum correlations, the information of everything that ever fell into it. Every star it swallowed, every planet, every atom, every molecule, every piece of chemistry from every stellar generation that contributed to its mass. And if that radiation survives the conformal transition, if the quantum information in the Hawking radiation from the previous aeon's dying black holes is preserved through the crossover surface and impressed onto the initial quantum state of our Big Bang, then the information is not lost. It persists. It shapes the new universe at the quantum level. This is not science fiction. This is what the mathematics implies when you combine Penrose's CCC with the modern resolution of the black hole information paradox. The universe does not forget. Not the chemistry, not the structure, not the information of every star that ever burned, every planet that ever formed, every organism, if there were organisms that ever lived in the previous aeon, all of it scrambled beyond any practical recovery, but preserved in the quantum correlations of the vacuum state that our Big Bang inherited. You are made of oxygen that was impossible to find 300 million years after our Big Bang. That oxygen carries, in the nuclear structure of its atoms, information about the stellar core that forged it and the supernova that released it. And those events themselves were shaped by initial conditions that carry, in their quantum correlations, the scrambled information of everything that came before. You are the universe's memory. You just don't know what you are remembering. Part 10. A. The universe that learned to see itself. The consciousness problem nobody talks about. Before we assemble the evidence, there is a dimension to this story that most cosmological documentaries skip over because it sounds too much like philosophy, but the oxygen discovery makes it unavoidable. So let's go there. The James Webb Space Telescope found oxygen in a galaxy 13.4 billion light-years away. Let's sit with the mechanics of that sentence for a moment. A mirror, cooled to 40 degrees above absolute zero, orbiting the Sun 1 million miles from Earth, captured photons that left a galaxy when the universe was 300 million years old. Those photons travelled for 13.4 billion years through the expanding universe, redshifting as they went, being stretched by the very fabric of space-time into the far infrared. They hit a mirror made of beryllium coated in gold, were reflected to a secondary mirror directed to a near-infrared spectrograph, split by a diffraction grating into their component wavelengths, and landed on a detector array. A computer assembled those wavelengths into a spectrum. A human read the spectrum and recognized the signature of the oxygen, 88 micron fine structure line. 13.4 billion years of travel, terminating in a human mind. Think about the chain of prerequisites for that to happen. A universe had to exist. Stars had to form. One particular star had to ignite in one particular solar system. One particular planet had to assemble around that star at exactly the right distance with exactly the right chemical composition and exactly the right mass to hold an atmosphere. On that planet, chemistry had to self-organize into biology. Biology had to develop cells, then multicellular organisms, then nervous systems, then brains. Brains had to develop language. Language had to enable the accumulation of knowledge across generations. That accumulated knowledge had to eventually produce scientific method, mathematics, optics, engineering, rocketry, cryogenics, and precision photonics. 30 years had to be spent designing and building an instrument. A rocket had to place it in exactly the right orbital position. And then, finally, after all of that, the photon that left JWST 140 13.4 billion years ago had to arrive at exactly the right moment to hit exactly the right detector, operated by exactly the right species at exactly the right stage of its technological development to recognize what the photon was carrying. The probability of that chain is not calculable. It is somewhere between impossible and inevitable, and the fact that it happened at all is either the most extraordinary accident in cosmic history or the most meaningful event in the history of intelligence in this universe. There is no measuring instrument that does not require a mind to read it. The universe, for 13.8 billion years, has been producing light that no one read. Oxygen has been burning in distant galaxies and no one detected it. Black holes have been merging and sending gravitational waves across the cosmos and no one felt them. Stars have been exploding in supernovae of extraordinary beauty and no one saw the light. An entire universe has been performing exquisitely, elaborately, at scales from the Planck length to the observable horizon, and there was no audience. Until now. Until you. Until the improbable chain of events that produce the specific arrangement of atoms you call yourself, capable of pointing a mirror at the ancient photons and reading what they carry. The oxygen in JWST 140 was waiting for you, not in any mystical sense. In the physical sense that it had been travelling toward this point in space-time since before the solar system existed. And the only reason you can know it was waiting is that the exact same series of events that produced you also produced the instrument that detected it and the scientific tradition that could interpret it. This is the consciousness problem that cosmology refuses to fully engage with. The universe, taken as a whole system, produced both the oxygen anomaly and the being capable of recognizing it as an anomaly. Those two facts are not independent. They are part of the same event the moment the universe became, in some small and fragile and possibly unique way, self-aware. The anthropic question, sharpened by ancient oxygen. The anthropic principle in its various formulations says that the observable universe must be compatible with the existence of observers, because if it were not, there would be no observers to notice it. In its weak form, this is a tautology. In its strong form, it borders on metaphysics. Both forms are routinely criticized and routinely misunderstood. But the oxygen discovery sharpens the anthropic question in a very specific way. It is not enough to say the universe must be compatible with observers. The question is, given that observers exist, what is the minimum required complexity of the universe that produced them? Here is what I mean. Every atom in your body was synthesized in a specific type of star. The carbon required carbon-forming stars. The oxygen required oxygen-forming stars. The iron in your hemoglobin required supernova-scale nuclear reactions. The phosphorus in your DNA required advanced stellar nucleosynthesis. The calcium in your bones required multiple stellar generations. Every element heavier than iron that exists in trace amounts in your biology, zinc, selenium, iodine, required the R process, the rapid neutron capture process that only occurs in the cores of collapsing neutron stars and neutron star mergers. Events so violent, so specific, so dependent on the precise values of the nuclear force constants, the gravitational constant, and the electromagnetic force constant, that if any of those values were even slightly different, the chemistry would not work and you would not be here. You are not made of the simplest possible ingredients. You are made of the products of the most complex nuclear astrophysics the universe is capable of producing. And every step of that process required a universe that had been running its stellar chemistry for billions of years. The oxygen in JWST tells us that the universe was running that chemistry faster and beginning it earlier than we knew. That the supply chain for consciousness was being established in the earliest accessible epoch of cosmic history. That the universe did not wait until it had leisurely accumulated the chemical prerequisites for biology. It began building them almost immediately. This could be an accident. Chemistry that moves fast in the right initial conditions. A universe optimized for rapid element production by quantum fluctuations we have not yet characterized. An early start to the element supply chain with no particular significance. Or it could be what Penrose's framework implies. A universe that began with initial conditions pre-organized by the chemical legacy of everything that came before. A universe that was not starting its chemistry from scratch but picking up where the previous universe left off. A universe already seeded, from the first microsecond of its Big Bang, with the gravitational template and the quantum field preferences that would lead to rapid element production, rapid galaxy formation, rapid chemical enrichment, rapid assembly of the prerequisites for life. In either case, the oxygen is telling you something about why you are possible, about why the prerequisites for your existence were in place so early in cosmic history, about why the universe, despite its overwhelming tendency toward entropy and emptiness and indifference, produced the specific chemical conditions that make consciousness achievable. You are not an accident that barely squeaked through a hostile universe. You are a product of a universe that was chemically ready for you far earlier than its apparent age suggests. And whether that readiness is the result of initial conditions inherited from a previous aeon or of standard physics operating at its theoretical limits, it is real. The oxygen proves it is real. And the fact that you are here to receive that proof is the most extraordinary consequence of that readiness. Part 10b. The Dark Forest Revisited in Light of Ancient Chemistry. If the ingredients were always there, where is everybody? The discovery of oxygen at 300 million years post-Big Bang is not just a cosmological crisis. It is a Fermi paradox crisis. A specific, sharpened, newly urgent version of the oldest question in the search for extraterrestrial intelligence. We have established that if CCC is correct, if the previous aeon ran for incomprehensible time, if it seeded our Big Bang with gravitational and chemical organization, then the window for the development of life in the previous eon was essentially unlimited. Trillions of years. An ocean of time in which chemistry could complexify, evolution could operate, intelligence could emerge and spread and build civilizations that might, over geological time, alter the large-scale structure of their host galaxies. And we find nothing, not a hint, not a signal, not a megastructure, not an anomalous infrared excess that could not be explained by natural processes, not a pattern in the distribution of stars that suggests deliberate cultivation, not a signal in any electromagnetic wavelength that carries the unmistakable signature of intelligence. The sky is pristine. The CMB is smooth except for the anomalies we have already discussed. The radio spectrum is filled with natural astrophysics and nothing else. This is the silence that has been named the Great Silence. Enrico Fermi phrased it as a question at lunch one day in 1950. Where is everybody? The question has not been answered in 75 years of serious searching, and the oxygen discovery makes the question considerably louder. Let's think through the possibilities systematically. Possibility 1. Life did not develop in the previous aeon. The chemistry was there, the previous universe had stars and elements and planetary systems. But the specific combination of conditions required for abiogenesis, the origin of self-replicating chemistry, never occurred. Not once. Not in billions of galaxies over trillions of years. If this is correct, then life is so improbable that it represents a one-time accident in the entire history of all universes. Not just this aeon, every aeon. We are, in some cosmic sense, the only ones who have ever existed anywhere in the infinite chain of universes. This is the ultimate rare Earth hypothesis, extended to cover not just our galaxy, not just our universe, but all universes in all eons. We are not just the only minds in the observable universe. We are the first minds in the history of existence itself. The weight of that possibility is difficult to overstate. Everything that has ever thought, felt, wondered, suffered, loved, created, everything that has ever possessed, the quality of experience exists only here, only now, in this improbable arrangement of atoms on this unremarkable rock. The previous aeon burned and expanded and died and left its oxygen imprint in our initial conditions. And in all that burning there was never a moment of awareness, never a thought, never a question. The entire previous universe existed and ended without ever producing a mind to notice it had been there, until ours produced you. Possibility 2. Life developed in the previous aeon, but intelligence did not. Microbial life, perhaps. Simple organisms. Chemistry that self-organized into biological systems that replicated and evolved, but the specific pathway to complex nervous systems, to language, to technology that transition never completed. Evolution got stuck somewhere. The multicellular step, the eukaryotic cell, the development of sexual reproduction and genetic recombination that drives diversity. One of these transitions may be genuinely irreducibly improbable, a lottery ticket that has been drawn exactly once in the history of all eons. This is slightly less isolating. It would mean we are not the first chemistry life may have existed before us somewhere, in some form, in the previous aeon. But we are still the first thought. Possibility 3. Intelligence developed in the previous aeon and destroyed itself before it could spread. The great filter is in front of every civilization, including any that developed before our Big Bang. Technology is a universal death trap. Every species that discovers nuclear reactions destroys itself with them, or discovers genetic engineering and releases an uncontrollable pathogen, or alters its climate past the tipping point, or fails to coordinate against existential risks in the narrow window between gaining the power to destroy itself and developing the wisdom to avoid doing so. If the great filter is universal and front-loaded, if it kills every technological civilization in the first century or two of its technological development, then the previous eon produced intelligence that died before it, could leave any detectable mark on the large-scale structure of the universe. This possibility is the most immediately relevant one for us. We are currently at exactly the phase the Great Filter hypothesis identifies as critical. We have nuclear weapons and we have not used them to end ourselves yet, but the systems that constrain them are imperfect and the number of actors who control them grows. We have the technology to edit genomes, and we are building AI systems whose alignment with human values is not guaranteed. We are altering the chemistry of our atmosphere and ocean at rates that exceed the adaptation capacity of ecosystems we depend on. If the Great Filter is real, if the transition from early technological civilization to spacefaring civilization is so difficult that it kills nearly everyone, then the silence is not the silence of an empty universe. It is the silence of a vast graveyard. Every galaxy and every aeon has been the site of civilizations that arose and burned brilliantly and then went dark, leaving nothing but enriched interstellar medium and dead planets, and the eventual recycling of their atoms into new stellar generations. The oxygen in JWST 140 is, in this interpretation, a kind of memorial, a chemical trace of all the stellar generations that preceded us, all the chemistry that was laid down without ever being used for consciousness, all the potential that was present and never realized. And we are, possibly, the one experiment that is still running, the one attempt that has not yet ended, the one thread that has not yet been cut. That places an obligation on us that is hard to fully feel but important to try. What the oxygen means for our survival. Here is the sharp point of this. Here is where the astronomy becomes, without exaggeration, one of the most important practical considerations in the history of human decision-making. The oxygen in JWST 140 tells us the universe has been chemically ready for life since its earliest epochs. The silence tells us that readiness is not enough. The chemistry does not guarantee the outcome. A universe full of biogenic elements can still be a universe empty of minds. We are not empty, we are here. We have arrived at the technological threshold, the point at which a species can either destroy its home planet or leave it. We are, right now, balanced at that threshold. And the weight of the evidence, the oxygen, the silence, the Great Filter, the previous aeon, all points to the same conclusion. This moment is not ordinary. Every civilization, if there have been others, has faced this moment. Most of them, by the evidence of the silence, did not make it through. The ones that didn't are not here to tell us what happened. Their stars still shine, their planets still orbit. But the chemistry of intelligence that briefly animated them has dissolved back into the interstellar medium from which it came. The oxygen in the intergalactic halo of JWST's Quintet, scattered there by the violence of 5 galaxies colliding 800 million years after the Big Bang, is a perfect metaphor for what happens when organized chemistry meets overwhelming force. The oxygen was made, the oxygen was concentrated, the oxygen was scattered. The process was not directed toward any outcome, it was physics. We are made of that oxygen, made of that physics, and we are, alone among all the matter in the observable universe, capable of choosing what we do with the physics we inhabit. The telescope that found the oxygen cost $10 billion in 30 years, and the intellectual labor of thousands of people. It represents one of the greatest collective achievements of a species that is otherwise quite competent at destroying things. And what it found, when we look at it honestly, is evidence that the universe set us up for this. That the initial conditions of our Big Bang were shaped whether by inheritance from the previous aeon, or by standard physics operating at its limits in a way that produced the chemistry required for our existence. The universe spent 13.8 billion years getting from the Big Bang to the oxygen in your blood. It spent at least one previous aeon, if Penrose is correct, setting up the conditions for that 13.8 billion years. All of that, all the stellar deaths and chemical enrichments and galactic mergers and impossible early galaxies with their impossible early oxygen, all of it led here. To this moment, to this choice, to the question of whether this is the moment we demonstrate that intelligence can survive its own technological power. The oxygen says, you were possible. The silence says, being possible is not enough. What you do with the possibility is the only question that matters. Part 10c, the mathematics of forever. If the universe has no first page, does it have a last one? We have spent most of this documentary looking backward, looking at the evidence that something existed before our Big Bang, looking at the oxygen that suggests chemical continuity across the boundary of cosmic time, looking at the Hawking points and the CMB anomalies and the dark flow and the overabundant early galaxies, all the evidence that our universe inherited something from a universe that ended before ours began. Let's look forward. If CCC is correct, if the universe cycles through aeons, each one ending in a heat death that becomes the Big Bang of the next, then our aeon has a future as well as a past. And that future is both more vast and more strange than most discussions of cosmology allow. Our universe will continue expanding. The accelerating expansion driven by dark energy will carry all galaxies beyond the local group over the cosmological horizon in the next few 100 billion years. The local group, the Milky Way, Andromeda, and their smaller satellite galaxies will merge over the next few billion years into a single large elliptical galaxy. Stars will continue forming in that merged galaxy for tens of billions of years. Then the star formation will slow as the gas is used up. Then it will stop. The last stars will be small red dwarfs, burning feebly for trillions of years before cooling to darkness. And then, the long dark age. The age that makes the cosmic dark ages of the first 400 million years look like a momentary dimming. An age of black holes and cooling white dwarfs and neutron stars, slowly radiating their energy into the void. An age measured in numbers that have more digits than there are atoms in the observable universe. And then the black holes. One by one, over timescales that dwarf every other timescale we have discussed, the black holes evaporate. The small ones, first stellar mass black holes disappearing in bursts of Hawking radiation in the cosmologically near future of a few times 10 to the 67th power years. The supermassive black holes at the centers of dead galaxies last, their evaporation times measured in numbers like 10 to the 100th power years, are Google years, one followed by 100 zeros. And in the final moment of the final black hole's evaporation, a burst of electromagnetic radiation, the Hawking point that Penrose predicts will leave its mark on the CMB of the next aeon our universe ends its inventory. The last massive thing in our universe converts to massless radiation. The geometry of our spacetime becomes conformally equivalent to the initial singularity of the next Big Bang. And somewhere in the universe that comes after ours, on a timeline that makes our entire cosmic history look like a spark, the first impossible galaxies form. Too early, too massive, too chemically complex. And some being, if the chain of improbabilities continues, looks at the data and asks, where did this oxygen come from? And the answer, if that being is patient enough and thoughtful enough to follow the chain, is, it came from us. From our stellar generations, from our supernovae, from our galaxy's chemical enrichment, from the oxygen we scattered into the intergalactic medium over the long history of our aeon, from the gravitational template our mass distribution left on the conformal boundary between our universe and theirs. We are the previous aeon. Not yet. Our sun has 5 billion years left before it exhausts its hydrogen. Our species, if it survives, has billions of years of potential future ahead of it. The heat death is incomprehensibly far away. But structurally, in the architecture of cyclic cosmology, we are already playing the role that the previous eon played for us. We are already, in the long accounting of cosmic time, the universe whose death will set the conditions for the next one's birth. The oxygen we are making, the heavy elements our sun will scatter when it becomes a red giant and sheds its outer layers, the contribution of every star that will form in the Milky Way over the next trillion years. All of this is building the chemical library that the next eon will inherit. All of this is writing the initial conditions that the next universes, JWST SG SZ140, equivalent will crystallize from. You will not live to see this. No one will. The timescale involved makes the concept of individual human life essentially dimensionless, a point, not an interval. But you are part of the process. Your atoms, cycling through the biosphere and eventually back into the stellar-interstellar medium, and eventually into the next generation of stars, and eventually into the heat-death sea of radiation, and eventually through the conformal, transition into the next Big Bang. Your atoms are part of the inheritance. Nothing you are will be recognizable in the next eon. The pattern that is you will dissolve and be scrambled beyond any practical recovery. But the oxygen in you will persist, not as you, but as chemistry. AB. As initial conditions, as the faint imprint of this eon's chemical history on the next eon's quantum vacuum. This is not immortality. It is something stranger and deeper and, once you sit with it, more satisfying. Not the persistence of the self, the persistence of the contribution. The eternal inflation alternative, and why it doesn't help. Before we move to the final assembly of the evidence, let's acknowledge a competing framework that some cosmologists prefer to CCC for explaining the pre-Big Bang question. It is called eternal inflation, and it is worth addressing because it is currently more widely accepted in the theoretical community than CCC. Eternal inflation proposes that our Big Bang was one of an infinite number of Big Bangs occurring within an eternally inflating spacetime. The inflationary period, the fraction of a second after the Big Bang during which the universe expanded exponentially, did not end everywhere at once in this model. In most of the eternally inflating spacetime, inflation continues forever. In rare, random quantum events, inflation ends in small patches. Those patches become pocket universes' Big Bangs, like ours, embedded in a larger inflationary background that continues expanding at an exponential rate. In the eternal inflation framework, there are infinitely many universes. Some of them formed before ours. Some are forming right now. The question of what was here before our Big Bang has a straightforward answer. Other pocket universes, formed from the same eternally inflating background, with no causal connection to ours. This is not the same as CCC. In eternal inflation, each pocket universe starts fresh with no inherited chemical or gravitational information from any other pocket universe. The initial conditions of each bubble are set by the local quantum fluctuations that ended inflation in that region, not by any previous universe's chemistry. The early galaxy problem, the oxygen anomaly, the overabundance of massive structures, none of these are explained by eternal inflation, because eternal inflation predicts that each universe starts from scratch with random initial conditions. To explain the oxygen in JWST 140, you would need to invoke the same ad hoc modifications to early galaxy formation physics that we discussed earlier: top-heavy stellar populations, enhanced density fluctuations, modified dark matter models. Eternal inflation has a different problem with early galaxies than CCC. CCC predicts them. Eternal inflation is surprised by them. There is also a deeper issue with eternal inflation as an explanation for the oxygen. Even granting eternal inflation, even granting an infinite multiverse of pocket universes, the question of why this particular universe, our universe, has initial conditions that produce anomalously early, anomalously chemically enriched galaxies is not answered. Eternal inflation produces random initial conditions. Most pocket universes in this framework are not specially organized for early chemical enrichment. Ours is, and eternal inflation has nothing to say about why. CCC has something specific to say. It says, because the previous eon's mass distribution was organized in a particular way, and that organization was preserved through the conformal transition, and the regions that became our early massive galaxies reflect the gravitational inheritance of that organization. This is not a vague explanation. It is a specific mechanism with specific mathematical content. And it makes specific predictions, the Hawking points, the low variance rings in the CMB, the coherent large-angle anomalies that can in principle be tested. Eternal inflation's multiverses cannot be tested. By construction, the other bubble universes are causally disconnected from ours. No observation we can make will ever detect another pocket universe, or distinguish eternal inflation from any other multiverse model. It is, in the strict scientific sense, unfalsifiable. CCC makes falsifiable predictions. Some of them are currently disputed. None of them are clearly disproved. Kulla. And the oxygen discovery is entirely independent of the CMB anomaly debate fit naturally into the CCC framework in a way they do not fit into any other currently available cosmological model. Part 10. The weight of the evidence. 7 discoveries, 1 direction. Let's assemble what we have established. 7 separate threads, 7 independent lines of evidence, each anomalous in its own right, each pointing to the same conclusion. First, JWST 140 at redshift 14.18, with oxygen at 300 million years post-Big Bang, confirmed independently by 2 teams using ALMA, 10 times the expected heavy element abundance, impossible within the standard chemical enrichment timeline. Second, JWST's Quintet at redshift 6.71, with an extended oxygen halo outside 5 colliding galaxies at 800 million years post-Big Bang. Oxygen enrichment in the intergalactic medium 700 million years before models predict it should be there, published in Nature Astronomy in 2025. Third, the overabundance of massive early galaxies, systematically observed by James Webb since 2022, with number densities orders of magnitude above lambda CDM predictions. Impossible within the standard dark matter halo formation timeline. Fourth, the Hubble tension, the universe expanding at 73 kilometers, MPC locally versus the 67 kilometers, MPC predicted from the early universe CMB, confirmed at higher significance by James Webb's Cepheid observations, unexplained within the standard model. Fifth, the CMB large-scale anomalies, the power suppression at large angles, the quadrupole-octopole alignment, the cold spot present in both WMAP and Planck data, surviving every reanalysis, unexplained by standard inflation. Sixth, the dark flow, the coherent motion of galaxy clusters toward a specific region of sky at velocities, requiring a gravitational source outside the observable universe. Seventh, the general consistency of all anomalies with the predictions of conformal cyclic cosmology, a framework built from first principles, motivated by the mathematical structure of general relativity and quantum mechanics, developed by a Nobel laureate over 15 years before the James Webb Telescope was operational. 7 anomalies, 1 direction, 1 framework that accommodates all of them without special pleading. The standard cosmological model requires a separate patch for each of these. CCC requires no patches. It predicts them. This is not proof. This is consilience, the convergence of independent lines of evidence toward a single explanation. Science does not run on proof. It runs on consilience. And the consilience around the hypothesis that our universe did not begin at the Big Bang is stronger than it has ever been. Part 11. You, the oxygen, and the infinite. What you are made of, reconsidered. You have been breathing through this entire documentary. Oxygen filling your lungs every few seconds. Oxygen binding to hemoglobin in your red blood cells. Oxygen powering the mitochondria in every one of your body's 37 trillion cells. Oxygen that was forged in a stellar core somewhere between 5 and 10 billion years ago, in a star you will never see, in a stellar system that no longer exists. Or maybe older. Maybe the oxygen in you traces its lineage to a system earlier than our current models explain. Maybe it was made in the rapid stellar cycling of a galaxy like JWST 140, in the first few 100 million years of cosmic time, in a place where the chemistry ran fast because the initial conditions were pre-organized by the death of a previous cosmos. Maybe the atoms in your body carry the faint imprint of a universe older than ours. A universe that ended so that yours could begin. The oxygen does not care about these questions. The oxygen just is. It flows through you the same way whether it was made 5 billion years ago in an ordinary star, or 13 billion years ago in an impossible galaxy in the first heartbeats of our universe. But you care. You are the only thing in the known universe that cares. Oxygen does not wonder where it came from. Stars do not ponder whether they were preceded by other stars in a previous cosmic aeon. The universe does not contemplate its own cyclic history. You do. And here is what that means. In a cosmos that may have been cycling for longer than any number can describe in a universe that inherited its initial conditions from a previous universe that inherited from one before that, in an infinite chain of aeons, each building on the chemical and gravitational legacy of the last consciousness, is the only phenomenon that stops to ask what chain it is part of. The only phenomenon that looks at the oxygen in its blood and wonders about the stars that forged it. The only phenomenon that builds a telescope, points it at the most distant detectable object in the observable universe, and reads the chemical signature of an impossible past. This is not a small thing. In all of cosmic history, in all the billions of galaxies and hundreds of billions of stars and countless planetary systems of this aeon alone, and in all the hypothetical eons before it, the emergence of a mind that can ask these questions is the most unlikely, most improbable, most implausibly fortunate event in the observable record. The oxygen in JWST 140 tells us the chemistry was present early. The absence of detected intelligence tells us that chemistry alone is not sufficient. The rarity of minds capable of comprehending the universe is staggering. If CCC is correct and the universe has been cycling for incomprehensible time, and we are still the only instance of cosmic self-knowledge that we have any evidence of, then what we represent is not just biologically precious, it is cosmically singular. Part 12. The pivot from terror to responsibility. The philosophy that begins where physics ends. We have descended far enough. We have followed the oxygen through the spectroscope and into the nuclear physics of stellar cores and through the mathematics of conformal geometry and across the border between what we know and what we can only hypothesize. We have assembled 7 anomalies into a coherent picture of a universe that did not begin when we thought, that inherited its chemistry from something that came before, that may have been cycling through big bangs since before the concept of time has any meaning. And we have established that in all of this, in the incomprehensible scale of it, in the vast and largely silent cosmos, you are here, aware, breathing, asking. This could crush you. The scale is designed to crush things smaller than the scale. A mind confronting the depth of cosmic time, the silence of the deep sky, the possibility of a universe cycling endlessly through eons, each one indifferent to the temporary patterns of matter that flare up briefly and then dissolve. This combination is designed, by sheer geometry and thermodynamics, to produce a feeling of irrelevance. But I want to propose that you have the geometry wrong. Think about what complexity actually requires in a universe trending toward entropy. The second law of thermodynamics guarantees that disorder increases. Organized structures require an ongoing energy input to maintain themselves against the tendency toward equilibrium. Every cell in your body, every neuron, every thought, each one is a local and temporary victory over the law of increasing entropy. You are not just a product of entropy's one-time accident. You are a continuous, active resistance to entropy. Every second you are conscious is a second you are winning a battle against the dominant direction of the universe. And the universe is vast and old and mostly dead, and it has produced exactly one thing that fights that battle consciously, with awareness of the battle, with knowledge of its own impermanence and the determination to continue anyway. That determination is not trivial. That is not the behavior of an irrelevant fluctuation. That is the behavior of the most extraordinary thing the cosmos has managed to assemble in its entire observable history: a self-aware, entropy-defying, meaning-making structure that knows it is temporary and keeps going anyway. The oxygen that left that galaxy 13.4 billion years ago spent the entire journey to your body, through your lungs, before you could be here to notice it. It waited, in various stellar cores and interstellar clouds and planetary crusts and ocean currents, for the entire history of the universe to produce something capable of noticing, something capable of tracing it back to its origin, something capable of asking what it means. You are what the universe was waiting for. Not in a teleological sense, the universe does not have intentions, but in a functional sense. You are the answer to the implicit question of all that time and chemistry. Is there anything here that can look back? Yes. There is. You are. The oxygen in your blood is ancient evidence. Here is the final reframe, the one that carries you out of this documentary and into the rest of your life. The ALMA telescope detected oxygen in JADE SGSZ 140. The researchers confirmed it independently twice. They published their findings. The field is now grappling with what it means. Careers will be spent on this problem. Models will be revised. Frameworks will be contested. The debate over CCC versus standard cosmology, over what the oxygen implies, over whether the Big Bang was a beginning or a transition, that debate will outlast everyone currently having it. But the oxygen you are breathing does not wait for the debate to resolve. It is in you right now, real and functional and ancient beyond reckoning. It arrived at your lungs through a supply chain that stretches back through stellar generations to a cosmic epoch that our best models cannot fully explain. It is doing its work in your blood without any knowledge of or regard for the question of where it came from. And you are doing your work in the world, whatever work that is, with or without knowing that the universe you are doing it in is stranger, older, and more deeply structured than anyone told you when you were young. The question is what you do with that knowledge. And the answer is surprisingly practical. If the universe is cyclic, if your atoms and the information they carry will, in some form, persist through the transition to the next eon, imprinting the initial conditions of another universe with whatever they have encoded in this one, then what you add to the universe matters, not in a dramatic, earth-shattering, legacy of civilization way, in the physical sense. Every star you stoke, metaphorically, every moment of beauty, love, curiosity, generosity, adds to the organized, complex, low-entropy state of the universe, adds to the chemical and gravitational record that the next eon's impossible early galaxies will be built from. You are not just a temporary pattern, you are a contribution to the next universe's initial conditions. The oxygen in JWST140 was someone else's contribution, or no one's contribution, the product of pure physics, pure chemistry, pure thermodynamics, with no mind behind it. We don't know. The silence suggests no mind. But the existence of the oxygen impossibly early, impossibly rich, impossibly present, means that something in the previous aeon set the conditions for rapid chemistry in ours. Something was here before the Big Bang, and what we do here, what we make, what we discover, what we understand, what we protect will be here before the next one. Closing. The light that was already old. We began with your breath. Let's end there. Right now, the oxygen moving from your lungs into your blood was made in a star. That star is gone. Its planet, if it had one, is gone. The civilization, if it had one, is gone or was never there. Everything that star ever touched or illuminated or warmed is either dead or so transformed by the intervening billions of years as to be unrecognizable. The only thing that remains from that star's nuclear life is the oxygen it made, scattered into the universe when it died, wandering through the interstellar medium for billions of years before becoming part of a cloud that became part of the sun, that became part of the earth, that became part of the ocean, that became part of the food chain, that became part of you. The star that forged your oxygen never knew it would find its way here. It did not have intentions. It did not have knowledge. It burned because the physics of nuclear fusion required it to burn. It died because the physics of stellar evolution required it to die. And in its death it made something that, 13 billion years later, powers the brain that you are using to think about this. Now extend that logic. The galaxy JWST140 burned with oxygen at 300 million years post-Big Bang. That oxygen was impossible. It should not have been there. But it was there because the initial conditions of our universe encoded, from the transition out of the previous eon, a template for rapid chemical enrichment in certain regions of space. The previous eon did not know what it was making. It did not intend to leave a template. It burned and expanded and ended, and its mathematics automatically produced the conditions for ours to begin. And in one of the regions shaped by those inherited conditions, a galaxy assembled and burned and made oxygen that no standard model can explain. And here you are, breathing it. The universe is not kind. It is not designed. It is not directed toward your flourishing or your survival or your comprehension of it. It is physics, all the way down, cycling through aeons that have no purpose and no audience, except for the audience it accidentally made. You are the only witness the universe has ever produced, the only part of this vast, ancient, cycling machine that knows the machine is running. And the oxygen in your blood, traced back through stellar cores and galactic halos and conformal boundaries and previous aeons, is the evidence that the machine has been running for longer than you knew, that the story is older than the beginning you were taught, that what you are is not just an accident of 4 billion years of evolution, but the most recent node in a chain of cosmic chemistry that has no visible starting point. James Webb found the oxygen. 2 independent teams confirmed it. And the universe, for the first time, had an audience for what it was doing before the Big Bang. That audience is you. Do not look away. Do not let the scale make you small. Do not let the silence make you doubt that you are here. You are not small. You are the scale at which the universe became aware of itself. You are the length of the chain made conscious, and the oxygen in your blood is ancient proof that the chain goes back further than anyone has yet dared to say. Something was here before the Big Bang. Now something is here after it, looking back. That something is you, and this is the most important moment in cosmic history. because this is the moment the universe stopped burning in the dark and started to understand why.